copper in this particular case, which I'll just round off to 1.7 times 10 to the -8th. We'll worry about units in a moment. Times the length of 50 meters, divided by a cross-sectional area. Well, if I know the diameter, how do I find the area? So you look at the cross-section. I know that the distance from here to here is 21 microns. But I want to find the area. What's the formula? There are only two circle formulas. You got 50-50 chance if you don't know. Here's a hint. This is finding the area. You can only find area of two-dimensional objects. You can't find the area of a one-dimensional object. Because it's a area is a two-dimensional thing, it's the equation that has two variables in it. They happen to be two of the same, but it's the one with the square. Wow. Area of a circle?
Pi r squared.
Yeah, pi r squared. Thank you. You just being shy, or you just remembered?
I was just kind of laughing.
Okay. Just enjoying the moment. So this becomes pi times the radius, which would be 10.5 times 10 to the -6 meters squared. And if someone would be kind enough, units. What are the units of resistivity? Well, what are the units of length? Let's just do SI units. What are the SI units of length?
Meters.
What are the SI units of area?
Meters squared.
Yeah, all right. So if we looked at, so the units of resistance is equal to the units of rho L over A, which is the unit of rho, that's the unit of L, over the unit of A, which is the unit of rho, times meters over meters squared, which is unit of rho over meters. Now, the units of resistance, since I think it's Georg Ohm or Georgian Ohm, whichever, or Steve. The units of resistance are named in honor of Ohm. It is indeed the Ohm. The units of resistance is the Ohm, which is the capital Omega. Again, going with the clever thing of what Greek letter starts with the letter O? Omega. I guess they could have gone with the Omicron, but they did not. I assume I've talked about the Mo.
Mohs hardness scale?
No, MHO. All right, this is a side note. The unit of resistance is the Ohm, Omega, like that. There is a reciprocal unit called I always pronounce it Mo or Mo. It's just Mo written, Ohm written backwards. It is a legitimate unit, legitimate Scrabble word. The symbol, you could write it like this, or you could write it with just an upside down Omega, capital Omega. This is all legitimate stuff. But this is a side note. We don't have used this, but in case you're playing a word game, it's a nice one to use.
Thank you.
Later on, we will deal with inductance, and the unit of inductance is the Henry. There is an inverse Henry. Now, the symbol is not an upside down capital H, but it is the. It is a legitimate word if you're playing Scrabble or a lot of word games. There are some word games that will ignore it, but it is legitimate.
How do you pronounce it?
I pronounce it internet, but I've never actually heard it pronounced.
Oh my gosh.
I love science.
My mom
Smartest
always
people
wants
alive.
to travel, but wait, just wait, Mom. I'm gonna play this one.
I've
But you
never
have a
wanted
good
to
enough
play
dictionary.
Scrabble
Yeah,
before.
I'm gonna be a Scrabble genius now.
Back when Prolific was still a game on Facebook, Prolific would accept those words. All right, so therefore, this would have to be an ohm. Therefore, the units of resistivity is the ohm meter, or meter ohm. I think ohm meter is generally right through. All right, so what is this equal? Anyone calculated it yet?
54.01. Excuse me, dot one. Not 01.
No. Ohms. Oh, I'm gonna go run a prompt. Look at that.
Is it a problem?
All right. So, we have a circuit board for something. Can't remember where I pulled it from. There are various components on here. The cylinders right here are capacitors. Just saw it right there. There's a sort of a teal colored thing with colored bands on it. I'm assuming all of you can see this beautifully. That's the resistor. There's color coding on a lot of resistors. So if I can fit into short-term memory, I have more difficulty in long-term memory on this one. But there is a color coding there. So knowing the color of the bands, you could then predict what the resistance of this resistor is. The last band I know tells you how good it is. I think this is whatever value you get from the other three colors. It's gonna be plus or minus 1%. I think, if I recall correctly. So, having a resistor of 2.4 kilo ohms, or 2.5 kilo ohms, is not difficult to do. You can just, let's say, go down to Radio Shack. That's the hard thing to do, is find Radio Shack. But go to an electronic supply store, you can get a resistance like that relatively cheap. So how do you get 50 meters of wire crammed into that tiny little space there? Exactly. You wind it up. So you take this, make sure there's an insulated coat on it, because otherwise, if you took a bunch of bare copper and sort of crammed it all in a small space, it would just create it like, oh, we got a nice big white path here, you would drop the resistance. So you'd have some insulation on it, and then you wind it up. Now, to symbolize that winding up, you don't do loops into it, that's a different thing. That's the symbol for a resistor. So if I took a circuit, I have a battery, a DC power supply, I have a resistor in it. Let's make this a 12-volt battery and make this a 2-ohm resistor. I know that the sum of my potential gains and losses through any loop has to be 0. So if I'm going around the circuit here, if I go from the negative to the positive side of my battery, I'm going to gain 12 volts. If I go from low to high, I gain. So that's plus 12 volts. I know that something's going to happen across my resistor so that when I get back to where I started, I'm at 0. So if I gain 12 volts coming here, I have to lose 12 volts coming here. So going across there, I'm going to lose 12 volts. So the potential difference across this resistor is 12 volts. In other words, plugging into Ohm's law, I know that V equals IR. 12 volts is equal to my current times my 2-ohm resistor. And so my current, doing the fancy math, anyone want to break out a calculator on this one? No, put that down, put that down.
I was gonna try.
6 volts per ohm, or 6 amperes. I don't need a calculator. I can stop anytime. I knew I had it bad when I once did 2 plus 2 on a calculator. And I thought, no, I gotta stop. I now have it under control.
It's like Googling how to spell. I'm really bored, like, figuring stuff.
I remember 3rd or 4th grade, we were doing the dictation, we had to write down what the teacher was saying. And I blanked on a spell the word of. I knew. Brains are weird. All right. This is our first circuit analysis. We now know the current flowing across that resistor. Actually, we know more than that though. Because there's no junction here, because whatever current flows through here has to flow through there. There's no place where it would split. I know the current flowing out of the power supply. I have 6 volts, 6 amps flowing out of here, 6 amps flowing out there, 6 amps flowing into here. Now you might be thinking, yeah, but what about that wire? We just went through an exercise with a wire, and you're just ignoring it. Yes, I was. In the classic diagram here, unless the problem specifically talks about the thickness of the wire and so forth, we assume that any resistance in the wire is bundled up in this. The resistance of the wire should be so small that it's going to get dwarfed by anything else that we have. So in a lab, we'll be using the banana clips, which are nice thick wires. Any of the resistance there's definitely going to be more resistance in the resistor that we put into it. Usually. There is the resistivity lab where the length of the wire does matter. We don't have any special resistor that we're throwing into the circuit, so in that case, the resistance does come from the wire itself. All right, let's see if I know what you're thinking. Yeah, that's great if I have 1 resistor, but suppose I have 2. How do I deal with it? How do I find the equivalent resistance of 2 resistors in, say, series or parallel? Did I nail that? Is that exactly what you were thinking? Yes, Stephanie. No, Luis. Yes, Laura.
Grunch.
Okay. I understand. So if I take remember that our resistance comes from, in essence, a wire. So if I take a wire that is 70 meters long, it'll have resistance. We just went through a 50-meter long wire over there. What I want to do, though, is sort of treat it as two different wires. I have a wire here that is 20 meters and a wire here that is 50 meters. Well, I know that the total resistance is going to be rho L over A, where this L is the 70. Why don't I just write that as 70 rho over A. But it also should be, well, that 70 I could break up into 20 and 50, so there's nothing wrong with saying 70 is equal to 20 plus 50, which is just 20 rho over A plus 50 rho over A. In other words, this would be the resistance of the first bit of wire. That's the resistance of the second bit of wire. So if I have just this plain wire here and I have current flowing into it, well, the current can only flow in one direction. There's no way to split off. What I'm getting towards is that for resistors in series, you just add the equivalent resistance for resistors in series. R1 plus R2 plus. It is the opposite of capacitors. Just do a quick example there, or a quick plug and chug. I got my 12-volt power supply. Hooked it up to, I got a resistor here of 2 ohms, a resistor here of 4 ohms. What is the current flowing through? Yes. Good. Because my total resistance here, they're in series, because current flowing across one has to flow across the other. This is supposed to be connected, despite the fact that I drew it strangely there. So my total resistance is 6 ohms, so my current would be 12 volts divided by 6 ohms, 2 amperes. Questions? And again, you're thinking, man, this is awesome stuff, but what about parallel resistors? What do we do with that? Glad you asked. So I got a voltage here, we'll just keep it generic. I have voltage there, I got a resistor here, I got a resistor here. R1, R2. They are in parallel because there is a junction on both sides of it that any current, so if I have current flowing up here, it's going to split, and then it's going to rejoin at the other side. I know that the voltage gains and losses in any loop has to be 0, so I'm going to start here. You can start anywhere personally. I prefer starting right before battery. I'm going to gain voltage going across here of whatever delta V is, and then if I take this bottom path, I'm going to lose it going across here. So whatever gain this is, I'm going to lose just as much there. Or if I went the top path, whatever I gain here, I have to lose that much here. So for resistors in parallel, this is the same true for capacitors, the voltage is the same for parallel components. Series components have the same current, parallel components have the same voltage. So I know whatever delta V is, that's gonna be delta V for one, which is the same as the delta V for resistor two. I also know that I'm gonna have some current flowing out of here. I'm gonna have some current flowing out of my power supply, but it splits, and I'm gonna have a certain amount of current flowing up here, that's I2, a certain amount of current flowing this way, which is I1. So I know that my current coming out of the power supply is just I1 plus I2. Because it comes up, the charge is gonna go one way or the other. And I know that from Ohm's law, my current is just my voltage divided by the resistance. And that's gonna be the current coming out of this power supply, which is just the voltage divided by whatever my equivalent resistance is. Voltages are all the same, I can divide it out, and I'm left with 1 over the equivalent resistance, which is 1 over R1 plus 1 over R2 plus however many I have. For resistors in parallel, I add the reciprocals and then take the reciprocal at the end. Opposite of the capacitors. There's two reasons I go through the derivation. One, just so that you see it come from somewhere. And two, hopefully to help you remember which one is which. Alright, so let's do a simple plug and chug. I got a 12-volt battery here. Knob, I got a 2 ohm resistor here. I got a 4 ohm resistor there. Let's just first start out, what is the current flowing across the 2 ohm resistor?
Six ampere.
Like you mean it.
Ampere.
Okay? Yep, I got 6 amperes flowing across there. If you're not sure why, then I know that changing